Hello and welcome. In this video, we are going to demonstrate how to configure and verify ISIS for IPv6 address family on JUNIPER routers. We have 6 routers on our topology, and right now, all the devices in this topology have been configured with their IPv6 addresses, and each of them can communicate with the directly connected devices. Host 4 can communicate with router 4, host 5 can communicate with router 5, host 6 can communicate with router 6. But communications cannot go from host 4 to host 5 and host 6 respectively. After testing that this communication is not effective, we are going to configure ISIS on these devices as shown on the screen. Router 4 and router 3 are in area 1. Router 1 and router 2 are in area 2, and router 5 and router 6 in area 3. Router 3 and 4 are going to be configured as L1 routers. Router 5 and router 6 are going to be configured as L2 routers, and router 1 and router 2 are going to be configured as L1L2 routers. As you might know already, in ISIS, routers can build adjacency only with other routers of same routing level. So router 4 and router 3 would be able to build adjacency because we will configure them as level 1 routers. Router 3 will be able to build adjacency with router 1 and router 2 because these two routers are going to operate as level 1 and level 2, both of them. And router 5 would be able to build adjacency with router 6 because both will be operating at level 2. And they will be able to communicate and build adjacency with router 1 and router 2 because these are operating at 2 levels, level 1 and level 2. Now let's go on the devices and start by testing connectivity, then doing the needful configuration. Here on host 4, if we issue a ping to 2001 db8:4::1, the ping is successful. That's router 4. Now, if we ping 2001 db8:5::5, not successful. If we try to ping also host 6 db8:6::6, the ping is not successful. So this is the proof that right now we can reach to those devices. Now let's go and configure various routers and we will test later. Setting the configuration right here on router 1. Let's first look at what is currently on the routing table. In the routing table, only directly connected routes and local routes are in the routing table. Now if we go into configuration mode, let's start by attributing a router ID to this router. Routing options, router ID 1.1.1.1, and then now let's attribute an NSAP address to the router. Go into interfaces, set family ISO address 49.0.0.0. This router sits in area 2 with router 2, and the system address is 111. So this NSAP address is made up of 3 parts. The first part identifies the area in which the router is sitting. The second part identifies the router itself in the ISO, and this third part says the type of device. This is a router. There you go. Now and in an ISO network, a device is identified by one NSAP address. So let's enable ISO on the other interfaces. The other interfaces are GIN 00 unit 0 family ISO. Same for 1 and 2. There you go. Now we want to configure ISIS. So edit protocols ISIS. Here under the ISIS subconfiguration mode, we will enable the level. This router is operating at level 1 and level 2. So level 1 white matrix only. Same for level 2. We will now enable ISIS to route IPv6 unicast address family. So IPv6 unicast. Let's add the interfaces which we want to be participating in this IS routing. So we have 4 interfaces: loopback 0, GE 000, 001, and 002. Let's start with loopback 0. This is a passive interface, and from interface GE0/0/0 unit 0. So this interface is point-to-point type. This is interface GE000 operates only at level 1. So we don't want the router to be sending LSA for level 2 on this interface. So the metric 10 and the IPv6 unicast metric also 10. Now the next interface is interface 1, and this interface connects to router 5, and router 5 happens to operate in at level 2 only. So we want to enable it for level 2 only. The metric 10, IPv6 unicast metric 10. What about the last interface, interface 2? It operates at level 1 and level 2. It's connecting to a level 1, level 2 router, which is router 2. So that's it for this router. We can now commit the configuration. At this point, if we show IS overview, you can see the configuration. So the router ID is 1.1.1, the system ID 111.111.111, the area ID area 2, and that is it. If we show IS interfaces, what do we get? We can see here that interface 0 is operating at level 1 and level 2. On this other interface, it is operating level 1, level 2, level 1, level 2 everywhere at this point. And the loopback interface is passive. If we show IS adjacency, right now there is none. You can also view the IS link state database, which right now it's very empty, and we can also view the SPF protocol, the SPF algorithm. Oops, let's do it brief. There you go. So everything is very dormant at this point. Let's see by configuring router 2. Here on router 2, if we show the routing table, we will notice that it can see only the local and the directly connected routes. Let's do the needful configuration. We will start here by setting a router ID 2.2.2.2. Now let's edit the interfaces to set the NSAP address. Here 49.0002 is in area 2, 2222.2222.2222.00. We want also to set the GE0/0/0.0 participate in the ISO address family. Same for interface 1 and interface 2. Now let's configure IS here. First thing, we want to enable IPv6. The level here is 1 and 2. Now let's add interfaces this process. So interface loopback 0 is passive. Interface 000 unit 0 connected to router 6, so it's point to point, and it should be operating at level 2. Interface 1 connects to router 3 and should be operating at level 1. Then the last but not the least, interface 2 is connecting to router 1. So now we can commit and quit. If we show IS, let's say adjacencies, there you go. So we have one router that is connected. The system ID is 1111.1111.1111. Now if we show IS, let's say the link state database, you can see here we have level 1 and level 2. So we have level 1 database and then we have the level 2 database. This is because on an IS router, the router keeps a database for each routing level. If we now show route, what do we get? We can see there are some IS route here. Now let's configure router 3. On router 3 here, if we show the routing table, only local and connected routes are here. So let's do the configuration. We will start here by setting the router ID. The router ID is very, very important when you configure a routing protocol. I will start by setting a router ID because the router ID is the identifier of the router in the routing domain. Now let's configure the interfaces. We'll start by loopback 0 unit 0 and okay, What's wrong? Oh, ISO address 49.000. This router is in area 1 and the ID, let's give it 3333. Now let's also add the other interfaces to the ISO family. So we have interface 0, interface 1 and interface 2. Now let's configure the ISIS process. Here let's start by setting the level. So for this router 3, we want to be operating at level 1. So set level 2 disable, and for level 1 white metric only. And then now the topologies for IPv6 unicast. And then we want to add the various interfaces. So interface loopback 0.0 here. So this is a passive as usual. And then the next interface is GE000 unit 0. This is a point-to-point interface, and it is operating at level 1. For interface 1, interface 1 is also operating at level 1. Interface 2 also operating at level 1. We could leave the default configuration, just that we don't want to overwhelm the links with unnecessary updates from level 2. So that is what we need for the configuration. Is that simple? So right now, if we show the ISIS overview, this is what we have on the router. So the routing ID 3.3.3, the host name is router 3. Here is the system ID 3333333. It's in area 49.0.0.1. So if I show ISIS, what are the neighbors? Oops, so far I have no neighbor. So let's troubleshoot what is wrong here. So if I show ISIS interface, what do I get? You can see here the interfaces are disabled for level 2. They are enabled for level 1, and 0 disconnects to router 1, disconnects to router 2. So let's go to, and disconnects to router 4. Let's go to router 1 and see what. Here on router 1, if we show ISIS interface, we can see this is good. So if we show ISIS overview on this router, level 1 is okay. Level 2, show ISIS adjacency, you can see only router 2. Oh yeah, so in ISIS, only level 2 routers can establish adjacency with routers in a different area. So let's now set this router to be able to handle route level 2 as well. So if we go to configure, then we do edit protocols, ISIS, here set level 2, set interface GE-000.0 level. We want to disable level 1 on this interface, then level 2 IPv6 unicast. We want to do same for interface 1. Okay, commit and quit. Show adjacent, show configuration. So oops, level 2, we have to delete this. Okay. Interesting. Disabled for level 1. Yeah, so this we want to remove. Now let's see what we have here. ISIS adjacency. There you go. So router 2 is up. What about router 3? Show ISIS interface. So here, this is good. This is good at the interface level, and here we connect to router 2 and it's good. Router 1, but we can't see router 1 as a neighbor. So now let's go on router 1 and troubleshoot. Okay, so here on router 1, I can see a problem here. Level 2 has been disabled. So let's remedy that. Edit protocols, ISIS, delete. And there you go. So we have router 3 and router 2. A bit tricky here. You need to understand how all these things works. So if we show routes, what do we have? We have directly connected routes, local routes, and we must have some ISIS flavors. Yep, yes, there you go. Okay, so now let's configure the rest of the routers behind the scene. Let's pause the video and we'll get back soon. So now we're back on this router 1. If we show ISIS adjacency, we can see that all the routers, the neighboring routers, are up and well. So if we show the ISIS interfaces on this, we can see all the participating interfaces 0, 1, and 2. If we show the routing table, apart from the connected routes, we are also learning routes from all the routers to router 4, router 5, and so on. So I might want to reach to router 5, look back address, for instance. There you go. What about router 4? All sounds well. So this is how you configure and verify ISIS for IPv6 on Juniper. I hope this video was useful, and I hope you will keep the IPv6 love.